working as an assistant professor in National College of Technology, the Department of Computer Science and Technology. Today we are going to see a seminar video conducted by our student Ashwin on the topic Repeated Measure of ANOVA.
So first of all, repeated measures of ANOVA checks whether in the given sample statistically significant difference among the three or more dependent variables. So dependent variables or samples. Okay, first what is dependent samples? So for example, if 5 persons, 5 patients are being tested. So there are three times the test is being taken. So the time period, the independent variable is time, but the patients are dependent. So for the 3 trials, the values are dependent. So the values are dependent upon the patient status. Here the time will be independent and the patient status will be dependent. The next values will be dependent to the first value. So it is called as the dependent samples. And the independent sample means it does not depend on anything in the next times. Okay, so this is the dependent sample. So repeated measures ANOVA is mainly specifically used in the 3 or more dependent samples cases. Okay.
We will see an example for this one.
In this example, we are going to see the repeated measures ANOVA solved. So a group of 6 students is tested after using 3 different study techniques to see which method is better. So we are using 3 different techniques for the 6 students. So because of this criteria, we are going for repeated measures ANOVA. So this is the given data for 6 students. The 3 technique has been applied. Okay. So the first step of repeated measure ANOVA is we want to write the given. So we want to organize the given data. The first step is organizing. We want to write as it is again in the solution part. And the second part is we need to find the mean and grand mean of the given organized data. So we are adding for student A, technique A, technique B and technique C, and we are finding technique A, technique B and technique C, and we are finding the mean for technique B and C separately, and we are adding so find the grand mean, we are adding the overall mean of this and divided by 3 because 3 techniques has been used. So that is the grand mean. So computing the sum of squares. So how this is the formula to compute the sum of squares. So we need to apply for x of ij, we need to apply 75. This is the x of ij value. So 75 minus the grand mean value is 75.94, the whole square. So like this we want to find for each and every step of the students. And overall we need to add the sum of squares for every student. The overall summation value is the answer for every student. Okay. Find the complete square. We need to apply the 3 values in this formula, and we want the summation of that. Likewise, we need to find for the 6 students. So the overall SST means sum square of the totals. We need to add all the given values, all the summation values of the 6 students. So the summation value is the SST value. Okay. After that, the fourth step is sum of the squares of treatments. Treatments means the value inside the organized data. So for the formula is n into summation of x bar t minus grand mean the whole square. So here the n value is 6. So 6 is the number of students here they given. And x bar of A means mean of A. We have already found the mean of A is 72.83, mean of B is 75.67, and the mean of C is equal to 79.63. So we need to apply this formula. So x bar of A minus grand mean. Our grand mean value is 75.940 whole square. So we need to find for technique B and technique C as it is, and we want to add the value for that. So the value is 21.23. So we need to multiply this with the n value as it is given in the formula. Our n value is 6. So 6 into 21.23 value is 127.33. So this is the value of SST treatment. This is the formula, and we are taking the n from the question, and we are substituting from the previously found value. Next step is we need to find the sum of the subject, sum square of the subject. The value is b into summation of x bar s minus grand mean whole square. There we apply the mean value of the technique. Here we are applying the mean value of the each student. So we need to find it q. So to find the mean value of student from the organized data, we need to find students mean hour. So divided by 3. Likewise, you substitute this formula in everything means you will find the mean of each student. So next we want to, after finding the mean, we want to apply into the formula. We already find the grand mean square in step 2. So 80 minus 75.94 the whole square, the value will be 16.84. So likewise, applying all the mean values and grand mean values, and we are finding the SSB. So the overall summation will be 216.30 for 6 students. And we are multiplying it with the B value. Our B value is 3. So the SS subject value, the sum square of the subject value is 648.90. Okay. After finding the sum square of the subject, we are finding the last value, sum square of the error. So to find the standard sum square of the error, we are subtracting the SS treatment value, subject value from the already find the SSC total value. So after we are substituting this value, after calculation we get the value 8.16. So the standard error value is SSC total minus treatment minus subject. So at last we need to find the mean square of the treatment. So for that formula is SS treatment divided by degree of freedom of the treatment. To find degree of freedom, we are subtracting from the overall K value minus 1. The value is 2. The 127.8 we already find that value divided by 2. The value will be 63.89, and the mean square error value is 8.16, which we find here, divided by 2. Degree of freedom value is 2, and the mean square error value is 0.82. So overall we need to divide these two values to find the F value. So MST divided by the MSC error value, we get 77.67. So in the interpretation of the solution, we will say the F value is statistically large for the given object.
Thank you.